Number 2, would a dilation alone be enough to show the similarity is transitive? That's a property that says if one is similar to another and that one is similar to something else, then they are all similar to each other. So if the original is similar to the first prime and the first prime is similar to the second prime, then the very original piece is similar to the second. Consider the 2 examples below. In part A, is a dilation enough to show that the original is similar to the double prime? Yes. Since these are all dilated from the origin, and the lines connect the corresponding points, it is enough to show they are similar. This is just like question 1A, because the lines are going through and matching up C, C prime, and C double prime, B, B prime, and B double prime, A prime, and A double prime. So yes, since they are all dilated from O, and the lines connect the corresponding points, it's enough to show. The only difference is the scale factor that they use. B, given ABC is similar to A prime, B prime, C prime, and A prime, B prime, C prime is similar to the double primes, is a dilation enough to show that the original is similar to this one? If I were to draw a line connecting B and B prime, or B double prime, and C double prime, and A with A double prime, are they all going to cross in the same place like they do on this last problem? It doesn't appear to do that. So we would say no, these are not aligned. So a dilation is not enough. We would also need to translate rotate, and reflect. Or you could say we also would need rigid motions. So again, in part C, it says, in general, is a dilation enough to prove that similarity is a transitive relation? No. In some cases or situations, we also need rigid motions to move the dilated figures. In number 3, it says, in the diagram below, ABC is similar to A prime, B prime, C prime, and A prime, B prime, C prime is similar to the double primes. Is there a similarity between the original and the double primes? If so, describe the dilation followed by the congruence. Here, this one is 2, and in this one it is 4. So if we are starting with the original and moving to the double primes, we need to find the scale factor. We do new divided by original. And in this case, the side length is 2, and the original side length was 4, which is a scale factor that is the same as 1/2. So we are going to dilate. Our first step is to dilate triangle ABC by a scale factor of r equals 1/2. And we are going to do this from the origin. Currently, point A is at 1, 4. B is at 5, 4. And C is at 4, -2. If we do half of these, half of 1, we're going to do our temporary. Half of 1 is 1/2. Half of 4 is 2. Half of 5 is 2.5. Half of 4 is 2. Half of 4 is 2. And half of -2 is -1. So I'm going to graph these. That would be 1/2, 2, 2.5, 2, and 2, -1, which is this triangle here. Then I need to move it so it matches up with the 1 on the left side. I am going to step 2, translate. I'm going to go 1/2, 1.5, 2.5, 3.5, 4.5, 5.5, 6.5 left. No, that would not match it up. That would put the triangle like this. We want to go farther than that. So 1, 2, 3, 4, 5, 6, 7, 8.5. Translate 8.5 units left. So now my triangle should look like this. And finally, to get it to match up perfectly, we need to reflect. And we're going to reflect it so it flips it up. So we are reflecting over this line here, so it flips it to the top. Reflect over AB, this line here. And that is how we would describe our similarity. That is the describing the dilation followed by the congruence.